we are looking at secant lines and average rate of change. So the average rate of change, we're looking at like basically an average idea. So we are taking the y's, the change in y's, and dividing it by the change in x's. And these are the outputs, and these are the inputs. All right, and then we're usually given 2 points here. So basically, the change is defined as subtracting the two numbers with the biggest number coming first. So my favorite example is if I'm asking you, since you were 2 years old and to 5 years old, how has your age changed? From 2 years to 5 years, what is your change in age? Well, logically, you can know that the change is equal to 3 years, right? So how has your age changed from 2 years to 5 years? It's changed by positive 3 years. To find that mathematically, we would do the 5 minus 2. So notice it's the second one minus the first one. So that's a key idea for understanding that change is an aspect, is a formula for mathematics. All right. So we're using that same idea of change to analyze this average rate of change. So the average rate of change is just a fancy word for basically slope. So whenever I think about this, I always think of slope, which is basically y2 minus y1 over x2 minus x1. All right, now we're just getting into also the idea of a secant line. The secant line means that if we have like a curve or something, that we have these 2 points on this line, and we would, let me switch colors on it. The line that it forms here is a secant line. So that's the secant. And it's basically an approximation of the slope here. So we pick 2 points and it approximates the slope. All right, so let's go ahead and just plug these values in and go from there. All right, so I always like to label stuff. So I'll call this my first point, x1. I'll call this my second point, x2. Remember, these are inputs. It's over the interval from including 1 to including 5. All right, of this looks like a parabola here. So those are the x values. So first, let's go ahead and look at my x1 value. The x1 value is equal to 1. Plugging that in to our function, f of 1 is equal to 1 squared plus 5 times 1. And I'm just plugging it into this function right here, which is equal to 1 plus 5, which is equal to 6. So this is the point 1 comma 6. This is x1, y1, my first point. All right, so we're missing the outputs here. We'll go ahead and do the same thing to find y2. So x2 is equal to 5. Plug that into our function. So we're looking at f of 5 now. First, I square it. So 5 squared plus 5 times 5. This turns into 25 plus 25, totals 50. So here's my second point, 5 comma 50. This is my x2 value. This is my y2 value. All right, now we just plug it into our slope equation. Let's go ahead and clear this out of the way, the secant picture. All right, see if I have enough room. Let's get rid of this too, outputs and inputs, and just breaking down what slope is basically. They call it secant, but it's basically slope. All right, and then we'll go ahead and say y2. y2 is 50 minus y1. y1 is 6 over x2. x2 is 5 minus x1 is 1, and I get 44 over 4, which is equal to 11. Yep. So what is the average rate of change of this function over this interval? The average rate of change is 11 units. And remember, you can kind of think about it as 11 over 1. It's 11, but 11 over 1 idea is kind of what slope is defined as. So for every 1 unit of change on the x, there's 11 units of change growing on the y. So getting used to interpreting what the average rate of change means. And we're going in that direction. All right, but for this one, straight 11. Okay. For the next one, see if it's any different. And let's go ahead and clear so I can see it better. Slope of the secant line that intersects the graph of this function at x equals 3 and x equals 7. So I'd call this x1, I'd call this x2, and then you plug it in to find out what the y1 value is. So we need y1, so you plug it into here just like we did before to find y1. And then you also do the same thing for the second one to find y2, and you just plug it into your y2 minus y1 over x2 minus x1 equation, and that would give you the secant line here. All right. It looks like most of them are pretty similar to these.